Today, we are firing the babysitter. I'm Vasu, and in this video, we are building a self-healing watchdog, a system that detects crashes, verifies the error, and restores your service automatically, usually before you even notice it went down. I actually made this video because someone in the comments asked how to test disaster recovery for the Immich server. Answer is, you don't just test it, you automate it. That is the only way to sleep soundly. Because the problem isn't manual work. The problem is that I don't want to be on call for my own house. When we finish a day debugging systems at work, the last thing we would want to do is come home and debug our photo gallery. You need a system that manages itself so you can actually enjoy your hobby. Now, you might be thinking, this is over-engineered. Why not just a simple script? If you watched our last video, you know we rely on split brain architecture. Our compute is here, but our data is over there on NAS. So we can't just restart. We have to verify the infra first. Alright, let's go ahead and open up our Firefox. Now we'll type our n8n IP. As you can see, we don't have anything here, so let's start from scratch. Now everything starts with a trigger. We'll go ahead and add a trigger on schedule to trigger this workflow automatically. I am currently setting it to 5 minutes. You can go ahead and adjust this, but for a critical service like a photo gallery, frequent checks are a good idea. So we'll just, to keep things clean, let's go ahead and add a set node. So basically we'll use this node to define all our important variables like IP address and API endpoints. This way, if anything changes, I only have to update it at one place and not all over the workflow. So let's get started. Let's add a couple of fields. We'll also go ahead and add our NAS IP. You can get these API endpoints from docs. Let's execute this. Let me increase the font size a little bit. Let's tidy up the workflow. Next, we'll add a HTTP request node. Now let's rename this to Immich as API. This will be our heartbeat check. We are expecting a 200 OK response, which will tell us whether the service is up and running or not. All right. We don't require any authentication. Next, we'll go ahead and add. So this is our first bit of logic. This if node looks at the status code from our heartbeat. So let us execute the previous nodes. If we get a 200 OK, we are good. If anything else, that means there's a problem and we'll proceed ahead with the false branch. 200. Let's assume that Immich is down and we'll go ahead and from the false branch. Before we do anything, let's check if the NAS is online. So this would be another HTTP request node, but this time it's pinging my NAS. So let's use our fields, update the NAS IP. Again, let's go ahead and include the headers and status. Also, let us rename this to NAS Health API. Just like we did for our Immich Health API, we'll add another if node. Rename it to check NAS. And just like we did for Immich, we'll check if the NAS is online. If it is, we'll continue. Otherwise, we have bigger problem and we'll want to stop and send an alert. We'll edit the output and make it 400. Let's save it. And this output is pinned. So basically, it will not execute this API. It will just forward this data for testing. If I go ahead and execute, let's execute this again. And if I go ahead and execute this time it will go to the NAS Health API. We can see there's an issue here. All right, we need to add the bearer auth. So let's jump to our NAS. and get that data bearer token. So let me log in. Go to credentials, users, code unbound, view API keys. So you can see I already have an API key. Let's delete this. Now let's add another. We'll name it n8n and we'll keep it non-expiring. So we'll copy this to the clipboard. Go to the workflow again. We'll select predefined credentials type. This would be bearer auth. Go ahead and create new credentials. We'll name it NAS. Let's paste our credentials and save. If we execute this step now, it should work. Our API is wrong, so it is system, not system. And so rename this to set fields. Now if we go ahead and we need to unpin it so that we can get this and save. So we can see here that the API is executed. The check NAS went to the true branch. Go to the status code, and if it is equal to 200, we execute, which is true. Now here's a critical check. We are using SSH node to connect to the Immich server and run the mount command. We'll pipe that command to grep to check our specific NAS mount path. Let's go ahead and open a terminal quickly. SSH into our node. Let us quickly check if the data share is present or not. Now here we can see the data share is present. Go back to our SSH node. Now we'll rename it to get mounts. So we'll go ahead and check the mount status. But for the path, let's drag and drop from our set fields. Alright, we do not have the path here. So we'll again go ahead and execute this. We'll go to Immich Health API, unpin this, execute this step. And for our testing, as we did before, we'll go ahead and put it as 400. It says it does not have any credentials. Normally we would want to enter the private key, but for this tutorial we'll simply use the password. So let's enter the host. Username would be root, and let's enter our super secret password. Let's also rename this node to PVE and save. It tested the connection successfully. Let's go ahead and execute this step. We can see there's an issue. Grep has no input. Let's go ahead and execute this step. We can see the output over here. Next, we'll go ahead and add another if node. So this would check the output of our previous SSH command. Let's rename it to check mounts. We'll go ahead and check whether our mount include our data share or not. So let's go to set fields and let's grab our mount path. If this is true, then we go to the true branch. So if the mount is present, we can proceed. If not, we'll stop because restarting Immich without its data is a recipe for disaster. Next, we'll try to get the container status. So let's use another SSH node for this. Let's rename this to get container status. We'll execute it in the PV guide node and we'll execute the command pct status and our container ID. We can get the container ID from our set fields node. Next, we'll add another if node. This if node will look at the previous output of our status command and it will check whether the container is already stopped or not. Now we can see that the container is in running state. In that case, we'll go to the false branch. Now we'll go ahead and add the false branch logic. So first we need to stop the container. Since the container is already running, we'll go ahead and add another SSH node, pct stop, and add the container ID. Let's execute this step. Over here, we can go ahead and simply wait, but I would want to add a loop to make sure the container has time to stop gracefully. So before we add the loop, let's add a code node, rename this node to add iterations. Let's clear this. This code node will create a few more items and the next node will split it in batches with a batch size of 1 so that it can act as a for loop. We'll keep the iterations to 5. We'll go ahead and return this item. Let's name it items. Let I be 0 and we'll loop until the iterations. Each time we loop, we'll push the data into the items array. Let's just keep it something like iteration number. Next, let's go ahead and add the for loop. We'll keep the batch size to 1. Let me drag this a little to the left so that we have some space to work on. We'll delete this and we'll add a wait node. I'll set the wait to 10 seconds. This gives container enough time to shut down before we check for the status again. Next in the loop, we'll get the container status. So for this, we'll use a SSH node. PCT status and the node ID. Let's execute this step. Let's go ahead and check the container status. So if this returns that our container is in the running state, we'll go ahead and loop it again. So we'll check whether our container is in running state or not. If it is in the running state, then we'll loop over and wait for it to be stopped. But if it is actually stopped, then we'll go ahead to the false branch and start the container. To do this, we'll use an SSH node again and use the command pct start to bring the image up and running. Let me rename the nodes first. Check status 1 and we'll rename it start container 1. Let's go back to our if branch and let's rename it to check container status. If our container is up running, then we'll go ahead and stop it, do all this work. But if it is already stopped, we don't need to do all this. We'll simply start the container. So let's just go ahead and duplicate this. We'll connect it to the true branch and we'll keep it somewhere here. Let's drag the workflow to the left again. Now we'll use the merge node to bring these two code paths together. Whether the container was already stopped or we had to stop it, the next step is the same, to start it. So let's keep the mode as append and number of inputs as 2. We'll connect this node, this start container to input 2, and we'll go ahead in the settings and always output data. This is so that no matter which code path is executed, the merge node is always executed. Otherwise, it will just stop at the merge node waiting for the other branch to be completed, which in our case will never happen. So we are almost done. After starting the container, we need to do one final health check. This is same as our initial HTTP heartbeat request. So let's go ahead and duplicate that. We'll press Ctrl D to duplicate. And we'll connect it over here. Let's go to setting and add some retries. We'll keep 3 retries and each retry will be every 5 seconds. We'll unpin this data. Now we'll go ahead and do the final API check. If condition that we created earlier. Let's duplicate this node. Again, we'll simply go ahead and add this node to our Immich API health check. Let's rename our health to final Immich API. And rename our if node to final API check. All right, we're almost done. The next step is to send some messages. Whether we succeed or fail, we do need to know. So for this, we'll use Discord. Let's search for send a message. We'll use the webhook. It'll ask to create the credentials again, just like the TrueNAS. Now we'll go to our Discord. Let's go to our Discord channel. We'll click on edit channel, click on integrations, webhooks, SpideyBot, and we'll copy the webhook URL. So let's simply paste the webhook URL here and save. It'll go ahead and test the connection. Looks good to me. Here we'll enter a success message. Immich is up and running. Let's rename this to success node. Let's duplicate this node and we'll rename it to failure. And let's change the message to fail to start Immich. Now let's tidy up our flow. For now, if the mount is missing, we'll just go ahead and throw an error. And we'll just type a simple message, mount is missing on the node. Let's also enter the node name. Now you could add a node over here to automatically remount the drive. If you'd like to see a video on how to create a generic reusable mounting workflow, let me know in the comments. So now it's time to test this workflow. We'll go ahead and test the first half of it and see what happens. Execute the first part of the workflow. So it's checking the Immich health API. Alright, so there is a problem with the health API and the workflow stops. So we'll go ahead, go into settings, we'll add the retry 3, and on error we don't stop, we continue. Let us also go to our Proxmox node. We'll go ahead and shut down our Immich container. We can see that the container is now down. So let's go back to our workflow. Let's execute it till check container status to verify whether it's working or not. Now we can see that it's in the true branch because the container is already stopped. Now we'll go ahead and execute the entire workflow. So it will do the final Immich check. Alright, so apparently it's not able to start. Let's confirm whether Immich is running or not. Immich is running. Alright, it says invalid URL. So let's go ahead and remove this. Go to set fields and we'll add the Immich IP colon the port slash the API path. This looks like the correct API path to me. We'll go ahead and stop the container again and verify whether it works or not. Alright, let's go ahead and execute the workflow. Now we can see here we got a success message. If we go to our Discord, we'll press escape and we can see we just got another message. We'll go ahead to our check and we'll say if it is in the running state. So if this is true, then we go ahead and loop. Otherwise, we go and start our container. So let's go ahead to our PV guide and let's verify whether it's running or not. We'll start the Immich container. We'll go ahead and stop the Immich web service. Let's go to our workflow and execute this. It should go ahead and wait until the container is in the running state. Go ahead and start our container. You can see that it is up and running. Let's go ahead and save this and publish this workflow as version 1. We'll rename this workflow as auto heal. Let's go to personal and executions. So we'll go to Firefox and we are back online. Before I go, here is the obligatory fetch. I know someone in the comments is eventually going to ask about the hyperlink config I'm running here. I haven't covered it yet, but if you want a full breakdown of the dot files, drop a comment below and I'll put it in the backlog. Thanks for watching. If you found this helpful, please like, comment and subscribe. And I'll see you in the next one.